right, so this is really just saying like, all right, here's the equation. What did it do to the original f of x equals x squared? So, well, two things are different, right? There's the negative sign, there's the 1/3. The 1/3 is going to stretch it out. It's going to make it wider, all right? And you would say it's a horizontal compression by 1/3. I'm sorry, a horizontal stretch by 1/3. And then that negative sign is going to flip it upside down. So you're going to call that a reflection over the x-axis. All right, so again, that 1/3 on the inside represents a horizontal stretch of the graph by 1/3. The negative sign is going to be a reflection over the x-axis. So in other words, it flips it upside down. All right, let's take a look at this one. Again, two things happening from the original. You got the -4 on the inside and the +5 on the outside. The -4 is going to move it 4 to the right. So that's why you see it going 4 to the right. The +5 is going to move it up 5. All right, it might look like it's not 5 units. But that's because it is scaled 2 units per block. So that is 5. The other thing you should notice is they are the same shape, right? Because there's no multipliers, there's no coefficient on the x inside or outside, it's not going to change the shape. It's not going to compress it. It's not going to stretch it. So that is actually an identical shape. It might look a little different. That's just because you see less of the G than you do of the F. But if you were to put that on top, it would be identical. Okay. So that first part is talking about the 4 units to the right. And then that part is talking about the 5 units up. Okay. Let's look at the last one. Okay, so pause. You try these. You're just giving an explanation. So you're not actually doing the graph. You're just giving an explanation of what the g function would do to the f function, essentially. Okay. So first thing is, well, that would be a multiplier on the outside. So it would be a vertical compression. So a vertical stretch. Of 1/2. And then the +3 is a translation of 3 units to the left. What you can also do is, if you have a graphing calculator, which you do on your Chromebook, or maybe you have your own handheld, graph it. Just see what it looks like. Because if it's just asking you what it's doing, if this was an SAT question, if this was a PSAT question, if this was something on a test that I'm giving, whatever, you're going to have your graphing calculator. So I would just graph it and make sure what I'm writing in here makes sense. So again, you've got 1/2. The way you have to type 1/2 into the graphing calculator is 1 divided by 2. And then it's an absolute value bars. So you have to hit the math button over the number column. ABS is absolute value. And then it's x plus 3 in there. And let's graph. Okay. So that looks good, right? 3 units to the left, and it's actually a vertical stretch. Okay. Actually, I'm sorry, they're calling it a compression. Same idea, whatever. It's opening it up, right? So I actually got that wrong. I apologize. But yeah, so they're calling that a compression where it's vertically compressed down. Okay. If that 1/2 was on the inside, you would call it a horizontal stretch, but whatever. Okay. But it ends up being the same thing. All right, and the second one, again, two things are happening here. The +2 on the outside is going to move it up 2. So translation, 2 units up. Then the minus sign on the outside is going to reflect over the x-axis. Again, if you want to graph it to 2c, so negative absolute value of x, and then plus 2. Let's take a look at what that looks like graphed. Oh my gosh, my dog's barking. Okay. You see up 2, and then it is flipped upside down. That's reflecting it over the x-axis. Okay. We'll check our answer on that, and that looks good. All right, I didn't mess that one up, so that's good news. All right. Let me know if you have questions. Let's take a look at the next example.